I'm the student resources.
All right, guys, nap time.
Oh,
Yo, he was so.
Yeah, what time do we go?
This floor.
This floor, what time of shoes is this?
12.
And you're, are you? You don't know Italy? You stop.
I got a new needle.
I'm glad I remember.
Where do you see yourself living?
Hey, quiet down!
You guys enough, all right? I know we're all wound up and stuff to do this, but we have to, so that means we're all kind of looking up here, trying to get figured out how to do these kinds of problems. We are getting close on time in terms of we don't have any days together left. So I'm not going to be hitting every single problem because there are a couple things that we have to get to. But it is important that you know how to handle this. We talked about it last time. This is what we call a recursive formula. And the directions say find first by term. Now the first one is given to us. So we know that the first term is 3. This is not difficult. Here's my formula. I'm going to start by letting n be 1. If I let n be 1, and it makes sense to let n be 1 because that's our first counting number. So if I put in a 1 for all the n's, what does that equation say if I put a 1 in there? What's it say? A sub 1. No, a sub 2 equals 2a sub 1 minus 5?
Yeah.
I'm just putting in 1s for the n's. Now, the good news is, I know this. That is 3. So this is 2 times 3 minus 5, which is 1. So a sub 2 works out to be 1. Now, I'm going to let n be 2. What does my equation say if n is 2?
A sub 3
A sub 3 equals 2, a sub 2 minus 5. But I know a sub 2. A sub 2 is 1. So this is 2 times 1 minus 5, which is negative 3. So my first term is 3, my second term is 1, now I got negative 3. All right, now guess what I'm going to do? I'm going to let n be 3. Because if I let n be 3, what does my equation say? I'm doing 3. So a sub 4 equals 2a sub 3 minus 5. But I know a sub 3. What's a sub 3? Negative 3. So 2 times negative 3 minus 5 would be negative 11. This is not one of our special kinds of sequences. We're just generating. All right? Now you, Jimmy, you figure out a sub 5. Well, I'm ready to let n be 4. Because if I let n be 4, this will say a sub 5, and that's what I want. So let n be 4, and see if you can figure out what you're going to have. Because
That's out
here.
in math.
So 0 is how we got it.
And what's 1 plus 1? So this was
Yeah, you need to
given.
go to the finals. Oh, so you're just starting the city. You need to figure out the final days.
Yeah. All right, have you gotten a sub 5 yet? What did you get?
Negative 27.
Negative 27. How did we get negative 27?
Because you know A sub 4.
If we put a 4 in here, we're letting n be 4, it'll say a sub 5 equals 2a sub 4 minus 5. But a sub 4 is negative 11. So 2 times negative 11 minus 5, negative 27. All right, let's try one more. Let's try the next one. These, you're not generating anything special here. You're just generating the numbers of this random sequence. So this one is this. And we're told that the first term is 3 and the second term is 4. And we need the third and the fourth and the fifth. Okay? So how did we start last time? N equals 1. So if you let n equal 1, what does this say? If you put in 1, what does this say? A sub 3 equals a sub 2 times a sub 1?
Yeah.
We know A sub 4 is 3.
We know a sub 2 is 4 and a sub 1 is 3, so it looks like a sub 3 is 12. Right?
Yeah.
All right, what now? Let n be 2. And if you let n be 2, it says a sub 4 equals a sub 3 times a sub 2. But we know both of those, so that'll be 48. Now, once you figure out what's going on, you don't need to write everything out. Certainly you can if you want to, but basically, where did this 12 come from? We multiplied those two. And where did the 48 come from?
4 times 12.
We multiplied these two. So what do you think this one's gonna be? 12 times 48, right, whatever that is. So you don't need to write it all out. Once you figure out the pattern that's developed, you can go ahead and do it without working them all out. All right, let's look at number 5. Again, I told you we're gonna be having to skip a few things, so if we have time, we'll come back and do the fill-ins, but I don't think we're gonna have time. All right, consider the sequence. This comes back to what we talked about before. All right? Find the common difference or ratio. So in order to do that, we have to decide, is this arithmetic or geometric? In other words, am I getting from term to term by adding the same number or by multiplying the same number? And I hear people saying it's arithmetic because I am adding what? So my difference, it says find the common difference. The difference is -4. That is the number that we add to get from term to term. Now it says find the 8th term. Now one option would of course be to just keep subtracting -4, or subtracting 4, right? That would be an option. And if you're only going to the 8th term, not a bad option. But if you were going to the 80th term, that would probably not be a good idea. So did you happen to write down the arithmetic formula that I gave you? What is that?
A equals A1 plus,
So this is my arithmetic formula. Does anybody remember what this stands for?
the
First number. So I want the 8th term, so I'm gonna take the first number, and I'm gonna add my common difference times n minus 1. What's n? 8. Kids, look at your formula. See that n right there and that n right there? They're always the same.
How do we know?
And look what's right
Oh,
there,
yeah.
right? So this is 7. So 3 plus negative 28, what, negative 25? And again, I know you could have counted down. I have no issue with you counting down when there's only 8 terms. But if there's 800 terms, counting down would be, you can't do it. So we might be able to use our formula. All right, let's look at B. Oh wait, am I done? No. I need an explicit rule. This right here is your explicit rule. To make it specific to this particular sequence, we have to plug in our first term and our common difference. So our explicit formula will look like this. Now I'm not done with it, but that's the beginning of it. So this will always be the explicit formula or explicit rule for an arithmetic sequence. This will always be. But you want it to apply specifically to this sequence, so you put in that specific first term and that specific difference, and then distribute and clean it up. So our explicit rule is negative 4n plus 7. That's your answer. That's your explicit rule for the nth term.
So when the difference, I said explicit, it should be
Yes, absolutely.
the formula.
All right, let's look at B. Are you guys paying any kind of attention?
Oh, you'll,
Huh?
nothing.
No, times are 2. So we're up the,
All right, here we go.
well, the geometric.
So, consider the sequence. Give the common difference or ratio. Well, what's happening here? So our ratio is 2.
Yep.
This is geometric. What is our geometric formula? Anybody remember?
A1R to the n-1.
Yep. Now remember, I told you didn't have to memorize these, and you don't. Okay? But you have to, when you see a list of formulas, and we're gonna add to this list, you have to know, okay, this is my arithmetic A sub n formula, this is my geometric. All right? So I want to find, according to the problem, the 8th term, so that means A sub 8. A sub 8 will be our first term times our ratio to what power? 7, n minus 1. That n and that n are the same. In any formula anywhere, the same letter has the same meaning. It doesn't change in the formula. Okay, so 3 times 2 is 7. No. Oh, no. No. There's no 6's involved in
1,
this.
0, 0, 0.
It's 3 times 2 to the 7, which is 384.
So it's
2 times 3 to the 7. These two do not combine. Don't combine these. Remember PEMDAS?
Yep.
What comes first? And then exponents, and then multiplication, right? So we gotta do our exponent before we multiply. And you don't need to think about it, just type this in on your calculator. It will do it right. It will do it exactly like you're right there. Okay? And now we want an explicit rule. There it is. I need to make it specific to this problem. So I'm gonna plug in my first term, and I'm gonna plug in my ratio. So my explicit rule is gonna look like 3 times 2 to the n minus first. And that simplify. We just talked about it. You cannot multiply these. So that is it, that's your explicit rule. So kids, what this means is, if for some reason you wanted to know the 100th term, all you would have to do is plug in 100. Work it out, and that would be the 100th term. You don't need to do the whole sequence. Just get the 100th term. All right, I want you to try C right now. You answer all the parts of the question for problem C.
-3. Danville.
Really, before you can start, what do you have to figure out? Am I arithmetic or geometry? And what was your conclusion? With a ratio of? Perfect. As soon as you realized you were geometric, then you should have focused on this formula. So a sub 8 will be -6 times 3 to the, -3 to the 7th. So I'll just type that in on my calculator. I'm not gonna try to get tricky or fancy, I'm just gonna type it in. And I got 13,122, how about you? Now, I just graded a bunch of quizzes from another class, and they knew exactly how to set everything up, some of them did, but they kept getting wrong answers because they didn't know how to put it in the calculator. So when I'm asking you to participate, Cullen, let's, honey, type it in on the calculator, not just write down my answers, because we want to make sure we know how to type it in. You do, that would mean taking the cover off the calculator.
So on the equation test, will we be solving for the 1, 3, 1, 2, 2, or will we be solving for the equation like this? What's that?
Well, this is a two-part question.
Okay.
So this is the first answer. Now I need my explicit formula, which again is gonna come straight from here. And I'm just gonna plug in my first term and my common ratio. And now I can plug in whatever term I want. Please do not cancel anything in this problem. I know you see a negative and a negative, but whoa, whoa, whoa. This might actually be positive depending on its exponent, so don't cancel anything. Just leave it, just like that. That is your explicit formula.
So if we have that and then they ask for like the 27th term, we just plug in
Which is
27.
27. Explicit, if you want the 8th term, you just plug in 8. Cursive, if you guys want the 8th term, you have to do something to the 7th term. Okay, we have one more problem to do before we go lunch. All right, we're going to number 6 now. Part 6. Come on, guys. Last one, we're going to lunch. Maybe. I have an arithmetic sequence. And I know that the 4th term is -8. And the 7th term is 4. Okay, so that's, look at 6A, that's what that notation means. They tell me it's arithmetic. And the 4, I don't know what these are, but the 4th term is -8, 5th and 6th, I don't know, and the 7th term is 4. Now, what does it mean to be arithmetic? Adding the same thing. So in other words, I'll look at just this part. If I start at -8, I'm gonna add something, I'm gonna add it again, and I'm gonna add it again, and I end up at 4. So -8 plus 3 of those numbers, I'll call it the common difference, what I'm adding, will put me at 4. Does that make sense to everybody? I gotta get from -8 to 4 in 3 steps. So 3 D's is 12, and it looks like D is. Now again, I set up an equation. You guys, some of you are so smart, I'm sure you just got it in your head, and that's fine. Here's the idea. I've gotta get from -8 to 4, which is how far? How far is it from -8 to 4? 12. I gotta go to 12 steps, right, or 12 units. And I have to get that 12 in 3 steps. So each step has to be 4. Right? Now, the question says, find the first term. That's back here. So if I'm adding 4, going that way, I'll subtract 4 going this way.
Don't you know everything?
So -12, -16, -20, how's that sound? All right, when you get back from lunch, we'll do this. We're back at 30. Back at 31, okay, back at 31. Just be back.